is pretty straightforward. So I want to quickly tell you this, okay? Let's final focus, please. Radical equations now are equations that have variables underneath the radical sign, okay? So they could be square roots, they could be cube roots, etc., etc. Now, in order to solve for the variable, which means you want to remove the square root or the cube root, you will need to do something to it. If you have a square root, and if I want to get rid of the square root, what should you do? Square both sides. Exactly. Okay? Now, that part's easy, but the tricky part about these questions is you need to check to ensure that the answer is in the domain, also known as your right, NPVs and all that kind of stuff. Okay? Remember, when dealing with the square roots, the stuff underneath the square root must be greater or equal to 0. Exactly. Okay? So let's do example number 1, and then hopefully I can give you a little template, and then you can try to do the rest on your own, because this stuff shouldn't be too hard. Now, let's take a look here. If I asked you to quickly find the domain or your restrictions, what's your restriction in this case? Well, you have an x underneath the square root, so therefore x must be bigger or equal to 0. Good. Now, if I ask you to solve this now, what would you do? You want to have the root x by itself. So what should I do with the 3 first of all? Yeah, move it to the side. So I get root x equals to, now what's 12 divided by 3? 4. That's nice now. Not square root, but square both sides. So now when you take the square root of x and you square it, that just becomes x, and 4 squared becomes 16. Done. Yes, Sahil. Why can't it be equal to 0? Remember, I can take the square root of 0. That's still 0. So that's one possible answer, right? No, I'm saying that this is just a restriction on x. So if I didn't have the 12 here and I just had this expression, what numbers could it be? Now I'm saying, let's go ahead and solve and make sure your answer is part of your restriction. That's all. And of course, you can always check these. This is algebra, so you can always check. Just multiply this. Plug in x is 16. Well, that's 3 times 4. Yeah, that's 12. It's all good. Okay? Now, the rest is the same. So let's take a look. How about part B? What do you have here? Well, your restriction here will just be that 3x plus 7 must be greater or equal to 0. So 3x is greater or equal to negative 7, so x is greater or equal to negative 7 over 3. So these are the possible values for x that make the expression on the left side valid. Now you're hoping that when you solve, your actual answer is in this restriction. So let's take a look. How would I solve this question? I guess to get rid of the square root, I will square both sides. And if you square both sides, on the left side, you just get 3x plus 7. And on the right side, what's 4 squared? Just 16. Okay. Simple algebra. Let's go ahead and continue to solve. We'll subtract 7 off of both sides. That equals to 9 on the right-hand side. We'll divide both sides by 3, so x equals to 3. Is this in my domain that's possible? It is. So therefore, your answer is good. You can also check if you wish by plugging this in and solving, and I think this equals to 4. Okay.
Can you tell her, does he need to go after school?
Yep. After school. Okay. Okay. Why don't you guys now try part C on your own? Okay. So try part C. Oops. Am I actually recording this for now? What did I just do? Your restriction here should be what, first of all? 2x plus 5 is greater or equal to 0. So you solve, you get x should be a value that at least is greater or equal to negative 5 over 2, right? Yeah. Now, to solve this, my advice to you is move the 8 to the right side. Because if you don't and you try to square this, you're going to have a binomial, and when you square a binomial, you're going to have a middle term, which is still going to have the square root, right? Because if I had this, what was the question? 2x plus 5 plus 8. If you were to square this, that is, right? And if you were to multiply this out, you've got problems. 2x plus 5, that's good, but then you have these two things, and look, you still have your square root, so that's not good. Okay, bad. So what should you do? Move it to the side, separate and isolate the square root. Now you can square both sides. 2x plus 5 equals to, what's negative 8 all squared? 64. Go ahead and solve for this, and you get x equals to 59 over 2. And now, yes, Hisham? Right. Ladies and gentlemen, don't just say, well, hey, this value of x is in my domain. It works. I'm done. I want you to check. If you were to check this one by plugging it back in, notice what happens here. You get 64 underneath the square root, and the square root of 64 is positive 8, not negative 8, right? And 8 plus 8 is 16. So this one, despite the algebra working, it actually doesn't make sense. And we call this an extraneous root, meaning in this case, therefore, there is actually no solution, even though the algebra makes sense. And now you should have been able to spot this before I even squared it, because look what I'm saying to you. The square root of something equals a negative number. It doesn't work. Okay? So let me just finish it off by doing this now. Let me just give you a quick summary, and then I think I will be done for today, because I think my voice will be gone by then. First of all, find the domains or restrictions by setting the radicand to be greater or equal to 0. Step 2 says then, I want you to isolate the radical term, so I want the square root part to be by itself. Alex, Mavis, seriously, please, okay? And then I'd like you to now square both sides, because then you can get rid of the root. And I know that the first examples we've done, once you square it once, the radical disappears, but the ones underneath, you'll see that they don't disappear. So this is really for C example number 2. But the final one that I want you to always do for these radical equations is please check your answer, so you don't run into the same problem like example number 1C. Okay? So ladies and gentlemen, I think I'm going to stop here for today. Make sure you get your work for section 5.2 done, and you should be able to start 5.3 as well. Those of you who already handed in your formats, I'll give that back to you right now. And for those of you just handed in now, I'll get it back to you on Thursday.